Here I have a cylindrical pendulum. You see it swinging back and forth. Pendulum has an equilibrium position. I've got a washer. We'd really use something a little smaller, but here's a washer. And I've used a fairly large washer so you can maybe see it. In order to determine how fast this pendulum is moving at a point, all I have to do is stop it and allow the washer to slip off and undergo its projectile motion to some stopping point. So that, for example, if I want to find out the velocity of the pendulum at this point, simply pull it back to here and stop it at that point. Okay, we see how far the washer traveled. The washer actually made a little impression in the styrofoam. Now, if I can determine the distance that this thing was pulled back from equilibrium, and if I know the length of the pendulum, then I can determine how far the pendulum fell. Therefore, I can determine its change in potential energy, and from that I ought to be able to determine its velocity. I don't even really need to know the mass of the pendulum. I can let that be unknown, and the mass cancels out of the relationships that we use to represent the potential energy and the kinetic energy. And the details of that we're going to leave up to you. But if I can stop this thing, and it's best not to stop the thing just by whacking it, because it's a little bit hard to predict exactly where it is. It might be better to hold the thing. Let's say if you want to stop it at the equilibrium position, we'll just hold it there. And it went about the same distance as it did before. Now, I wasn't measuring my pullback, but if it had been the same pullback, it should have gone the same distance. If I want to determine the velocity of the system at a different point, well, that's a little more complicated. If you let the washer slide off at the equilibrium position, of course, its velocity will be in the horizontal direction. And that makes the projectile motion easy to analyze. Whereas if I stop it, let's say here, the projectile motion is much more difficult to analyze because we have a vertical component to the motion, and that analysis is a little bit more challenging, beyond the scope of some physics courses, well within the scope of others. The university physics course, that should be no problem. For a principles of physics course, we're probably not going to worry about that. In any case, that's the setup that we can use to determine the velocity of the pendulum at any point.